Hi, so this is a follow-up video about this epidemic simulator that I created. So in my last video, I showed you the default mode, which describes non-local interactions over space. So people are moving around by means of plane trips and also short trips and all kinds of different things that give rise to this very complex spreading pattern that I showed you in the last video. But a lot of older epidemiological models do things a different way. And so now I'm going to demonstrate that. So I'm going to click reset and I'm going to scroll down to change the model input. So what I'm going to do is when it says mobility type, so the default is this non-local mode, but now I'm going to switch to classical by clicking that button. And so what's going to happen here is now the model is going to assume that people just take short distance trips. And it's also going to assume that space is homogeneous. So the population density is the same everywhere. So this population distribution chart is just all one color. And so I'm going to click run. And so again, you've got this initial outbreak in that red square, and it's going to spread, but the spreading pattern is going to look very different now. Okay, so you can see the squares adjacent to that initial outbreak are changing, and it's spreading out from there. And so what we get is what's called a traveling wave. So this is like what you get in chemical reaction diffusion systems. And this is the way a lot of epidemiological models work. It's just a different set of assumptions about how things move around in space. And so this is part of a long-standing debate in science about how to model human mobility, how things move around, and how the modern international transportation network affects the spread of diseases. So lots of different assumptions you could make in different kinds of epidemiological models. And so different assumptions are going to be appropriate in different situations. But this is just showing one option. And so just hit stop. And that's it.